40. The average value of a certain type of automobile was $14,520 in 1991 and depreciated to $6,240 in 1995. Let Y be the average value of the automobile in the year X, where X equals 0 represents 1991. Write a linear equation that models the value of the automobile in terms of the year X. Okay, so what's the key here is we are writing a linear equation. So again, we have pretty much two options for starting this. We can think of our point slope form. Y minus y1 is equal to the slope times x minus x1. Or we can use our slope-intercept form, y equals mx plus b. This first one will always work. The second one is particularly nice when you know the y-intercept, when you know what the value of y is at x equals 0. In this case, we will. So I'm going to go ahead and think of that one there. Okay, so a couple options. So the first thing I got to do is figure out how I want to organize my information. You know, I am looking at writing the equation of a line. It's very helpful if I can think of this in terms of ordered pairs. One thing I would make note of is that we know that the value of the car in 1991, and then we also have the value of the car in 1995. So we have, you know, 14,520 in 1991, and then 6,240 in 1995. Well, we know this is the y value, right? Because y, we were told, you know, x is going to equal the year since 1991, and y is going to be the average value of the automobile. So y is going to be the value, x is going to be the number of years since 1991. So what is x equal to in 1991? It's going to be 0. They told us that. And then so in 1995, the value of x is going to be 4. Because the difference between 91 and 95 is 4. Okay, so now I'm kind of thinking I got these ordered pairs right here. And like I said, if you think of it, this is the ordered pair 0, 14, 520. And this is the ordered pair 4, 62, 40. And now you can treat it just like we have other equations of lines we wanted to write once we knew 2 points. Okay. I do know I have to find the slope. So regardless of which one of these equations I'm going to use, I need to know my slope. So slope is equal to the change in y's over the change in x's. Doesn't matter which one goes first or second, just be consistent and keep the x and the y's together. So this is going to be my first ordered pair, and then I'll use this one for my second ordered pair. So I'm going to have the change in my y's, so the change in the money, so 6,240 minus 14,520, all over then the change of the x's, so 4 minus 0. Or I could even use 1995 minus 1991, either way. So I end up getting negative 8,280 over 4. So my slope is going to be equal to negative 2,070. Okay, so now I know what the slope is. It's decreasing. So I got to plug it into one of these two equations here. Like I said, both of them work nicely. Use either ordered pair. I happen to know the y-intercept. You know, that's why I'm going to go with this equation. I'm going to go with the y-intercept form. So I know that y equals mx plus b. We just found what the slope is. Right? It's negative 2,070. And then what's my y-intercept? What's the value of y when x is equal to 0? You know, that's this ordered pair right here. That's 1991. So y is equal to my slope, so negative 2,070 x plus, and then the value in at time 0 is 14,520. And there's the function. And like I said, if you prefer, you can go ahead and use this equation here. You can plug in either ordered pair. Once you simplify it, you'll have the same exact answer that I do here. Number 45, solve the problem. Along with incomes, people's charitable contributions have steadily increased over the past few years. The table below shows the average deduction for charitable contributions reported on individual income tax returns for the period 1993 to 1998. Find the average annual increase between 1995 and 1997. So right here, find the average annual increase. They're asking me to find the average function value. So average function value. You can think of this as being a formula, but it really is the change in the y's over the change in x's. So it's like the slope, change in y's over change in x's. The main difference is that we're not necessarily talking about a line, so we don't think of it as slope in that sense. Okay, so change in y's over change in x's. So where do I want to look? What time periods am I looking at? So I want to go from 93 to 98. So 93, I'm sorry, this whole thing is from 93 to 98. I am looking for the function value between 95 and 97. So 95 to 97. So I want to go from here to here. And again, it's going to be the change in the y's over the change in the x's. So my average rate of change here is going to be, I have the 3,040 minus 2,480 all over 1997 minus 1995. And so I get 560 over 2, and that's going to equal 280. Okay, but now I got to think about what's the label on these. Okay, because that's going to be really important too. So remember, I took the change in the y's. So I took the change in these two right here. What's that being measured in? That's in terms of dollars. And then I subtracted it from these here. That was in years. So my label is going to be dollars per years. So the average annual increase is going to be $280 per year. And that's my average rate. We're asked to graph the function h of x equals 2 times the absolute value of x minus 3. So again, with this, it's going to be really important that you learn to recognize the different shapes of graphs based on their algebraic form. So when you see the absolute value, you should think about v. So it's going to look something like that. That's the basic one, kind of like the vertex centered here at 0. But we can shift it up and down, left and right. We may stretch it, we may compress it. We can also flip it around. Okay, so we also need to be familiar with all the transformations. So what I'd like you to do is go ahead and, like I said, recognize what the basic shape is. We have this right here. This is what the y equals the absolute value of x looks like. So what are our transformations on this one? What do they tell us to do? Okay. So the 2 here, this is going to be, we're taking all of our y values and multiplying by 2. So this is going to be a vertical stretch. And then the minus 3 here is going to be, again, if you want to think of it, it's when it's with the x, it's going to be horizontal. Outside is going to be vertical. So this is going to be down 3. So I'm going to take this graph here. I'm going to stretch it by a factor of 2, and then I have to shift it down 3 units. Okay. So like I said, so I stretch it. Keep in mind beforehand, like if I have the point, 0, 0, and I multiply this by a 2, it's just going to become 0, 0. When I have the point 1, 1 on this graph, and I stretch it by a factor of 2, then it becomes the point 1, 2. When I have the point negative 1, 1, and I vertically stretch it by a factor of 2, it becomes the point negative 1, 2. So it's going to get a little bit taller, a little bit faster. And then I'm going to also move it down 3. So 1, 2, 3. So now my vertex is going to be at 0, 3. And it's going to go like this here. So like that, I think it's a good idea to probably go ahead and pick 1 or 2 points just to make it a little bit more definite. But mostly what I'll be looking for is what you tell me about your transformations. So tell me that you're going to stretch it. Tell me that you're moving up, down, left, right. And like then it'll be clear from your picture what you've done. Number 52, use the graph of the function of f plotted below to sketch the graph of the given function g of x. So here I've got this unknown function, but I do know about the transformations. So let's talk about that. So I have g of x is equal to a negative f of x plus 2. So what do these mean? Well, this negative right here, that negative tells me I'm going to have to flip it, flip vertically. And I'll flip it upside down. So that means this graph is going to come down this way now. Oops, pick some points. All right. And then this plus 2 here says move everybody up vertically, up 2 units. So I want to take all these points here now in pink and move them up 2. And I get this graph here. Okay, so my final answer is going to be the one in green. Okay. Some students struggle a little bit with this. So a couple things I wanted to point out is think about the order that you should perform them in. Okay, so like if you were the number X, so let's go ahead and take, if I were going to go ahead and find G of 5, what would you do first? All right, so you do whatever this number is, but then you're going to do the negative part first. So you're going to have to flip it first. Then after you negate it, then you add the 2. So you're going to move everybody up 2 units afterwards. Okay. So let me go ahead and pick a couple of points that I can focus on and flip. So picking like these ones up here, I'm going to go with the -4, 4. I'm going to go with 0, 0. And then I'm going to go to the point with 4, 4. So I'm focusing on these 3 points right here. Now, the first thing I need to do is flip it vertically. That means I'm going to take the y value and multiply it by a -1. So the point -4, 4 becomes -4, -4. And 0, 0 will remain 0, 0, because I multiply 0 by a negative. And then the point 4, 4 becomes 4, -4, because I'm going to multiply my y value by a -1. Now I need to go ahead and shift it up 2 units. So now I'm going to be adding 2 to my y value. So I have the point -4, so I add 2 to the y value, becomes -2. 0, 0 becomes the point 0, 2. And then the point 4, -4 becomes the point 4, -2. And so like I said, maybe plotting those 3 points now in green will kind of give you some guidelines to help you, move your whole graph. For the given functions f and g, find the indicated composition. So we're trying to find f composed with g of 5. So I want f of g of 5. So think of this as being f of g of 5. So I'm going to take g of 5 and plug it into f of x. So my first goal is to figure out what is g of 5. So we go up to our g function. And wherever I have a 5, wherever I have an x, I'll plug in my 5. So I get 5 squared plus 2 times 5 plus 1. And so this will give us 25 plus 10 plus 1, or 36. So that's what g of 5 is equal to. So now f of g of 5 becomes f of 36. And then to find f of 36, I go up to my f function, right here, and wherever I have an x, I'll plug in 36. So we have 36 squared minus 2 times 36 minus 5. Let's see, 36 squared will get 1296 minus 72 minus 5. And so combining these, we'll get 1219. Okay, so you don't have to plug the function g of x into the function f of x and simplify it. You can do it for the function value, and that'll be a lot less work in this case. Find the domain of the composite function f of g of x. Okay, so when we're finding the domain, we have to consider not just the end result, but also the domains of f and g. Okay. So one thing you should make note of is that the function f of x, we do have this fraction here, so it could be an issue. For the function g of x, it's a polynomial, we have no issues, domain's going to be all real numbers. But we do have to go ahead and look at the composition. Okay, so for this domain here, let me go ahead and just write this down. So the domain, I've got to look at the domain of g, because that's what's going to be plugged into f of x, and I have to look at the domain of the composition. It's got to belong to both of those. Okay, so first let's go ahead and find this composition. So I want f of g of x, so I'm plugging g of x into f of x. So coming up here to my f of x, wherever I see an x, I'll plug in my g. So I got 4 over my new x plus 7. And I'll plug x plus 2 in there. So now simplifying, we have 4 over x plus 9. Right, so what is the domain of this function right here? Right, we can't divide by 0, so x can be anything but a negative 9. So negative infinity to negative 9. And then union the interval from negative 9 to positive infinity. So we got to take that domain and intersect it with the domain of g of x. But remember, when we were up here at g of x, we said it's a polynomial, so my domain is going to be all real numbers. Therefore, my domain for the composition is going to be negative infinity to negative 9, union negative 9 to infinity. Okay, question number 67. Find the inverse of the one-to-one function. Okay, so remember, when we're finding the inverse, the key here is we're going to interchange the x and y values. So I'm going to replace every x with a y and every y with an x. So over here for my function, I have f of x equals, so I'm going to start off with y equals 3x plus 1 over 4. And now I'm going to have to interchange my x's and y's. So I'm going to write it as x equals 3y plus 1 over 4. And now I'm going to have to solve this for y. So solve for y. So for my new y. I happen to have a fraction, so I will multiply both sides of my equation by the least common denominator to get rid of that. Or cross multiply if you like. So multiplying both sides by 4. I will have 4x is equal to, those will cancel, and so it's 3y plus 1. Keep in mind we're solving for y. So now I'm going to subtract 1 from both sides. So 4x minus 1 equals 3y. And then the last thing I need to do is divide by the 3. So y is going to be equal to 4x minus 1 all over 3. Therefore, the inverse, f inverse of x, is going to be equal to 4x minus 1 over 3. And if you want to, you can go ahead and check these by finding f of f inverse of x, and then also f inverse of f of x. If both of those equal x, then you know that you found the inverse correctly.